First, let's take a look at the history of theory of gravity. Most theories during this era were philosophical. Aristotle said there is no motion without a cause, and it is nature for heavy bodies to move towards the center of the universe. Galileo then noticed objects of different masses accelerated equally when in free fall. He noticed that heavier masses result in a stronger gravity than others. Then came the Newtonian era. Isaac Newton discovered that gravitational force was proportional to the product of the masses divided by the squared distance. With this, many accomplishments were made. Newton predicted the existence of Neptune due to Uranus's orbit and managed to confirm Kepler's law of planetary motion. However, Newton's formulation wasn't accurate enough. For instance, it couldn't explain Mercury's perihelion precession. This was finally explained by the general theory of relativity formulated by Albert Einstein. He describes gravity as the curvature of the space-time fabric, where a particle's path would be bent when mass is present, and is described by Einstein field equation. It is coined as the best theory of gravity, with its recent achievements such as the EHT black hole image and LIGO's detection of gravitational waves.
Now, let us look at the formation of the solar system. At the beginning of the formation, there will be a nebula exists in the Milky Way and contain interstellar dust in it. The nebula might be disturbed by a large event such as a supernova which could originate from the neighboring galaxy. The nebula will then collapse due to its own gravity and become smaller and smaller. Once the size reaches 100 astronomical units, the clouds will form a white rotating disk. The rotation is due to the momentum from the galaxy. Most of the matter are at the center of the disk due to the gravity. As the disk becomes smaller, the temperature will increase as well, which then causes the hydrogen bonding process to be occurred at the center of the disk and giving rise to the proton star. Then, the disk radiate energy and cool off. Now, let's proceed with this simulation for clearer visualization. The dust in the disk would collide and combine and forming the planetesimals, which then attract more dust with gravity and finally forming proton planets. The four closest planets to the Sun have the temperature above the water freezing point, which is a frost line, and are composed of rock. Four planets beyond the frost line are composed of ice and gases. In the solar system, large proton planets will slingshot the planetesimal, causing more collision and fragments into the smaller pieces, then further deflected by the proton planets, which then creating the asteroid belt. After a million years, the young sun will spill out strong solar winds, sweeping up all the remaining gases out of this halosphere.